So in case of motors, torque is the independent variable and speed is the dependent variable. Okay. Is this clear, everyone? As far as motors are concerned, torque is the independent variable and speed is the dependent variable. As the load changes, the load torque will change, the motor will try to match the load torque, and as the motor torque changes, the speed will change. Okay? The speed of the motor will depend on the motor torque, or speed will be a function of the torque. Omega will be some function of capital T, where T is the motor torque. So in case of motors, torque is the independent variable, it will be on the x-axis. Speed is the dependent variable, it will be on the y-axis. Okay, clear, everyone? Yes or no?
Yes, sir. Yes, sir.
Okay, so motor speed torque characteristic will also be defined as the relationship between the speed at which it runs and the torque it develops. Okay. Relation between the speed at which the motor runs and the torque it develops, that relation we will call the speed torque characteristic. Or omega is equal to some function of capital T, where T is now the motor torque. Have you seen any motor in which, as the torque increases, the speed also increases? Vikram, turn off your mic. There is some disturbance from your end. So have you seen any motor in which, as the torque, load torque or motor torque increases, the speed also increases? Give me one motor in which, as the torque increases, the speed also increases.
DC series.
Yes,
Sir, AC series motor.
AC series motor,
DC series.
DC series motor. As the torque increases, the speed increases. Anyone else? Nobody? Panag?
Sir, sir,
Yes, Ravinayak.
sir, torque increase, speed increase, power also increases, sir.
So which motor do you see these things?
Separated excited motors. DC series motors.
Okay. Anyone else?
So differential compound.
Differentially compound.
Differential
Differential
compound in unsaturated.
Okay. Anyone else?
Sir, this is the instability condition. I think
Yes,
no motor runs.
that is the right answer.
No motor follow this.
Yes, that is the right answer. Okay. Lot of times I'm going to ask you questions which have wrong answers, or the questions are going to be wrong, and only the person whose concepts are clear will be able to say no, this is not possible. Okay. Not all questions. Don't try to, every time I ask a question, you don't think that. So even if I don't know, anything about motors, I can say that in case of any motor, as the load increases, its speed is going to decrease. Correct? If in case of your motor, as the torque increases, the speed is also increasing, then as who answered? Akhilesh answered. Who answered? अखिलेश ने दिया था आंसर, किसने दिया था?
Yes, sir.
Unstable वाला.
Yes, sir.
If as you increase the torque, the speed also increases, that means your motor is unstable. Okay? Take any example. Suppose you are sitting in a car. 3 people are going and your car is going at some speed. If 3 more people come inside the car, is the speed of your car going to increase? Is it
Mass
possible?
increase.
No, sir, it will decrease.
No, it is not possible.
Mass.
Yeah, I told you when you are thinking, you should keep your mic off. Hmm? Don't think with the mic on. Okay. Okay. So in practically all electric motors, as the torque rises, the speed is going to decrease. The degree by which it decreases, that will depend on the motor. Okay. In some motors, there will be a large fall in speed as the torque increases, as we know in the case of a DC series motor. In some motors, there will be a slight fall in speed as the torque increases, as in the case of a DC shunt motor as well as an induction motor, what we call as shunt characteristics. And in one motor, or in some motor, the speed is going to be absolutely constant irrespective of the torque, and that is the synchronous motor. However, there is a limit to how much the torque can be increased. After one point, your motor is going to run out of synchronicity if you exceed the torque above its maximum allowable limit. Okay, is that clear?
Yes, sir.
So, similarly, the question that I had asked yesterday, the answer was not similar to one. Okay, we'll see the characteristic today. Okay. Characteristic one was the torque was constant, whereas in case of induction motor, the speed will remain constant. Okay, that was actually the speed torque characteristics for load. This is speed torque characteristic of motor, so they are different. Okay, so the degree by which the speed changes with change in torque differs for various kinds of motors, and we define it or characterize it by the so-called hardness of the speed torque characteristic. Okay? The term that we are going to use, or that is used in the book by Chilikin, is hardness of the speed torque characteristic. So based on this hardness, Chilikin has classified electrical motor speed torque characteristics into three main categories. The first one is absolutely hard speed torque characteristic. That is a characteristic in which there is no change in speed with the change in torque. I'll present my screen and I'll open. So, can you see the screen, Sumit?
Yes, sir. Yes, sir.
The diagram on the left hand side. These
Yes.
are the speed torque characteristics of motors that we are going to study today. So the first characteristic number one, that is the absolutely hard speed torque characteristic or flat speed torque characteristic, in which, as you can see, there is no change in speed, even though the motor torque is increasing or decreasing. This type of characteristic is exhibited only by the which motor?
Synchronous motor.
Synchronous motor. Okay. Wherein the speed has to remain constant irrespective of the load torque. However, there is a limit here. If the torque exceeds that limit, your motor runs out of synchronicity. Okay. The second characteristic, the second type of characteristic is hard speed torque characteristic. First one was absolutely hard. The second one is hard speed torque characteristic that you can see here as characteristic number 2, in which there is a slight decrease in speed as the torque increases. This type of characteristic is exhibited by DC shunt motors, separately excited DC motors, and also in case of induction motors. Now to the right, the diagram on the right shows you the speed torque characteristic of the induction motor, both in the motoring region as well as in the generating region. So as you can see this part, when I'm moving my cursor, are you able to see the cursor? Sumit?
Yes, sir. Yes, sir.
So this is the part of the characteristic that is drawn here, okay? Where the speed slightly falls as the torque increases. Once again, there is a limit, and called the breakdown torque. If you increase the torque beyond that limit, the speed is going to decrease. Okay? So, I think you have seen this speed torque characteristic of induction motor, and the part shown in quadrant 1. All of you definitely have seen it, drawn it, derived it. This here is your synchronous speed, correct? Yes. Here the speed is 0. This is the synchronous speed. As
Yes,
you
sir.
can see, if we draw a line here, this speed torque characteristic can be divided into two parts. Let us say this is part number 1 and this is part number 2. Where will the motor operate, in part number 1 or part number 2? In part number 1 or part number 2?
Part number 1, linear
Sir,
region.
both.
One, sir.
In part number 1 because it is linear,
Two,
and
sir.
also because it
Two.
is part 1 or part 2.
Part one, sir.
Yes. Part 1 because
One,
it is
sir.
linear, but more importantly because it is
Sir, let's sleep.
because it is
It is having ability to stable.
yes, because it is stable. This part is unstable. This part is stable. Don't know whether I can. Here, when you are thinking, turn off your mic. Hmm?
Sir,
Yes.
the third characteristic DC series motor.
I'm coming there. Wait. Actually, a lot of we are going to get a board and everything, but it has still not arrived. The college is giving to give us a board. Now, without board, it is slightly difficult. And if I want to, what do you say, draw something, very difficult. So I'll draw an approximate. Okay, I won't be able to get it exact. I'll try to draw and okay, so on the y-axis you have the speed, that is omega, and on the x-axis you have the torque. That was quite good considering. Okay, can you see this? This is the speed torque characteristic of the motor. This line here, okay, this is your maximum torque. So what I'm saying is this portion is your stable region and this portion is your unstable region. I'm writing here W instead of omega, but that is omega, the speed in radian per second, and here is the torque. Now my question to you is, what will be the value of speed of the motor? How do you determine the speed of the motor? Okay, I have the speed torque characteristic in front of me. How do I find the speed of the motor? Full answer.
Sir,
120f upon p, मतलब it can be find with the help of tachometer. Means how the formulas, or you are saying 120f upon p induction motor?
sir,
Wrong answer. Yeah.
sir, we
120
will
upon
plot a line parallel to omega axis, and at a particular value of t, where the parallel line where it will cut the graph, we will get the speed, sir.
parallel line means
So line perpendicular to torque axis, sir.
line perpendicular to torque axis, like this.
Yes, sir.
And where do I draw this line?
So for a particular value of torque,
Where? Should it be here or should it be here?
Sir, the second one.
First,
yes, sir.
second.
Second, sir. Because in the second time, sir, it is in the stable region.
Yes, sir.
Okay, I've drawn 4 lines here. Which line are you talking? First, second, third, fourth.
The first one is more stable.
Second line, sir.
Second line. Anyone else?
So the point where the load torque cuts the graph in stable region.
Repeat again.
So the point in the torque omega axis where the load torque will cut the graph.
Abhishek
That
Manu.
will be
Yes, that is right. You cannot draw a line anywhere. Is that correct? 1, 2, 3, 4, 5, 6. I can't draw a line anywhere. That line has a particular name, and the name of that line is the load torque characteristic. Not necessary that the load torque characteristic will be a straight line. It can be a curve also. Okay? But here, for the sake of simplicity, we will assume that the load torque characteristic is a straight line. Okay, is this clear, everyone?
Yes, sir.
We cannot draw a line anywhere. 1, 2, 3, 4, 5. Okay? The speed of the motor does not depend on the motor only. It also depends on the load. Okay? So now I'm going to draw the load torque characteristic, and I'm assuming that the load is such that its torque is constant. So let us say this is the load torque characteristic. Okay? Is this correct? Is the load torque characteristic that I have drawn correct?
Yes, sir.
Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
The answer is no. It is not correct. Why it is not correct?
Sir, it is cutting at the same time 2 points, sir.
Because it is less than the load torque.
What is less than the load torque?
So the torque desired to load is greater than the motor torque. But to run the motor, it should be greater than the load torque.
Motor torque should be greater than the load torque. No, that is not the
Sir,
answer.
load torque should be less than starting torque.
Yes, that is the answer. This motor will not start because the starting torque is less than the load torque. So the motor will fail to start. Okay? But we'll assume here, because we are interested in studying which part is stable and which part is unstable. So we'll assume here that we are starting the motor by some auxiliary means so that it starts. Okay, am I clear?
Yes, sir.
In practice, this is wrong because the starting torque here is less than the load torque, because of which the motor will fail to start. But here, because we are interested in studying what is the stable operating point, we will assume that the motor somehow starts. Now, once the motor starts, this is the point, the motor starts, it is possible to have 2 operating points here. One is the operating point capital A, and the other is the operating point capital B. which point is stable and which point is unstable?
A is stable and B is
Point
stable.
A is stable.
A is
A
stable.
is stable, sir.
A is stable and B is unstable.
Unstable.
Yes. Justify. Full justify.
Sir, whenever load will increase,
When I'm presenting my screen, I don't know the names. Who is speaking?
no need, sir.
No, chalo, no, bolo.
Sir,
Whenever.
whenever we increase the load, then motor speed will decrease, and to compensate that speed, we have to provide some extra current or extra torque. That means when speed will decrease, then the characteristics shown by motor should increase their torque, and in linear reason it is possible, sir. That's why it is stable.
Okay, how many of you agree with Navneet?
Sir,
The question, Kale, how many of you agree with Navneet? I
So
don't agree
induction
with
motors
Navneet.
work nearly on slip 0.4, 0.5.
Wait. Let me
Slip
say first.
slip means S is equal to 0.4, 0.5. Induction motor का always work. Means
Here, first let me finish. Let me uh, solve this Navneet's query. Then I'll come to you. Okay? So Navneet has said that if the load torque is increasing, है ना? So his starting statement itself is wrong because we are finding the stable or unstable equilibrium point. And stable or unstable equilibrium point is the point where motor torque is equal to the load torque. Okay? So when we are finding the stability of the point, we are not changing the load torque. Okay, Navneet, is that clear?
No, sir, I am not talking about load torque. I am talking whenever we increase our load, then our
If you
speed
increase
will decrease, sir.
if you
And
increase
to
the
compensate that speed, we have to provide some torque to
if you increase the load, speed is
yes, sir.
decreasing.
If we yes, sir, speed will decreasing, and at if speed is decreasing, then torque should be increased, sir, to overcome the instability, sir.
Okay. If you leave the first part of the sentence, now your answer is correct. Okay.
so
I'll
one
come
thing
back
I
to it
want to
later.
add, sir,
Now
if
Priya will
load
say.
is increasing, and torque should decrease. Means if I will increase the means speed will decrease. If I will increase the load of the motor, then speed should decrease. If means if load is we are increasing and speed both means torque means speed increasing, then what is the need with of means if speed will decrease, then we need more torque to maintain that speed. More torque to maintain means more power we required means more electricity. Means if load is increasing and less electricity is required, then it will be very better for us. Means load we are increasing and same electricity, same power is required to run that load, then it is
I,
it is
you are going somewhere else. Okay, Priya? I don't know where you are going. The answer to the question is very simple. I'll give you the answer now. Okay? Suppose your motor is operating at this point, at point number A, and there is some disturbance. And there is some, what is the word? Disturbance, not change in load torque, or the word is disturbance. And because of that disturbance, suppose your speed decreases. If the speed decreases, okay, this is the operating point, point number A. If the speed decreases, where does the point go? Does it go up, down, left, right?
sir, right. Sir, right.
Yes,
Right.
it will go to the right. There is no question of going it up or down. This is the load speed torque characteristic, not the motor. The operating point will always move along the motor speed torque characteristic. So because of some disturbance, if the speed has decreased, the point moves to the right. Let us say it has come here. Now at this point, if you see the motor and load torques, you see that the motor torque is greater than the load torque. So there is a net accelerating torque, because of which the speed will again increase and the point comes back to the point number A. Is this clear?
Yes, sir.
Yes, sir.
If due to some
Sir,
disturbance the speed increases and it comes
sir,
here, yes,
sir, I could not understand, sir. Please repeat once. Sir.
okay, I'm repeating. Just a minute. So this is the operating point. Okay, then the motor is operating uh, at this equilibrium point, and because of some disturbance the motor speed decreases. Decreases means this is the speed axis. Decreases means the speed has to come down. So if the speed comes down, it will move here. Now at this point, if we see, this is the motor torque and this is the load torque. So the motor torque is greater than the load torque. And because the motor torque is greater than the load torque, the accelerating torque, which is given by motor torque minus load torque, that is positive. So because the accelerating torque is positive, the speed will again increase and the point will come back to point number A. So operation is restored to point A. Conversely, if due to some disturbance the speed increases, comes here. Now as you can see, this is the motor torque, whereas this is the load torque. So the motor torque is less than the load torque, so the motor will decelerate and it will come back to the operating point A. So at this operating point A, if the operation shifts from here because of some disturbance, operation is restored back to the point A. That is why the operating point A is stable. Is that clear?
Yes, sir. Yes, sir.
Yes, sir.
Let us see operating point B. Suppose the motor is operating at point B and there is some disturbance because of which the speed decreases. Now at this point, we see that the motor torque is less than the load torque. And because the motor torque is less than the load torque, the speed will continue to decrease. So your operation is shifting away from point B, not towards point B. If due to some disturbance your speed increases, now at this point the motor torque is greater than the load torque, so the speed will continue to increase. So at this point, if there is some disturbance, the operation is not restored back to this point. That is why this point is unstable. This point is stable. Is that clear?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Sir,
Yes.
sir, why in this case we are taking omega as independent variable and omega is as a dependent variable and torque in independent variable. Before we are taking that torque as a in dependent variable and omega as independent variable.
Torque is the independent variable in case of motor and speed is the dependent variable. Speed will be a function of torque. Okay. I told in the starting of the class itself, in case of motors, speed is a function of torque. Okay. In case of generators, we are setting the speed. The torque will be a function of speed, but in case of motors, speed is going to be a function of torque. If you change the load, the motor torque will change, and accordingly the speed will change. Okay.
Yes, sir.
In case of, okay, it will be very clear. In case of motors, speed is a function of torque. Okay. So, as I was saying, this part is the stable region, this part is the unstable region. The induction motor will never operate in this region, even if there is equilibrium point here. That equilibrium point is unstable, so the motor will always operate in the stable region of its speed torque characteristic. And this stable region is drawn here as characteristic number 2. Okay? Check. Can I move forward?
Yes, sir.
We have seen two characteristics. First one was the absolutely hard speed torque characteristic that was exhibited by synchronous motors. Second one was the hard speed torque characteristic. We also call this as the shunt characteristic. And this is exhibited by DC shunt motors, separately excited DC motors, and in the case of induction motors when they're operating in their stable region or linear region. The third characteristic is the soft speed torque characteristic, where there is a considerable decrease in speed as the torque increases. This type of characteristic is seen in DC series motor. Okay? The slope, here if you find the slopes of characteristics 1 and 2, their slopes are constant. But for characteristic 3, the slope changes at every point. So we can say that the degree of hardness of the characteristic varies all along the curve. At any point along the curve, if you find the degree of hardness or the slope of the characteristic, it is different. Okay, so in this type of characteristic, as you increase the torque, the speed decreases by a very large amount. Okay, any questions here? I think we'll have to stop here today because new topic will start and the time is almost over. So, if you have any questions, I'll answer them. Any confusions?
Sir, hello. Sir, I have not understand the load torque characteristics.
Which one?
Load torque characteristics.
This one?
Yes, sir, OTL.
So the speed torque characteristic of the load, what we saw yesterday, do you remember?
Yes, sir.
This one.
Okay, sir.
For example, this characteristic, giving you the example, cranes hoisting a load will show this type of speed torque characteristic, but the load torque is going to be constant irrespective of the speed. Okay?
So you are asking that why it is there?
Why? What is there?
You have drawn 4 lines. My network is so weak. So.
Yes, 1, 2, 3, 4. I drawn. Yes.
Yes, sir. I can't get it.
So this characteristic can be anywhere, but that anywhere depends on the load.
Yes.
Your same crane will show different. For the same crane, this line will change depending on how much load you are putting on the crane. If you are putting a light load, that line is here. If you increase the load, that line shifts here. If you go on increasing the load, the line keeps on shifting. Is this clear now?
Yes, sir. Now it is clear.
Sir, I have a doubt, sir.
There are some disadvantages of teaching like this, but there are some advantages also. In this line, I cannot move on the blackboard, but I can move it here. Yes, somebody was asking something.
Yes, sir. Sir, I mean the DC series motor that is used in electric chain, but we already see that if we increase the torque of that DC series motor, the speed will be very less. So if the train become very crowded and load become very high, so in that case, how the train will answer?
कहाँ पे है characteristic? Wait, this characteristic ना. Actually, in case of the train, a major portion of the torque required is for hauling the train itself, and there is a lot of static friction. So this high load torque that you see, high load torque requirement that you see, that is only at the time of starting the train. As the speed, this as the speed of the train goes on increasing, its torque requirement goes on decreasing. Okay, so actually the speed torque characteristic of DC series motor exactly matches the speed torque characteristic of the train. Okay.
Sir?
Yes. Was I able
Sir,
to?
is this the reason why, sir, engine dislocated at the starting, at the time of starting of the train?
फिर से repeat करो. Is this the reason why engine?
Sir, why, sir, engine dislocated, it creates some gap, sir, after, before starting, sir, it pushes the train, sir, and then when it starts, sir, it is little bit dislocated from the other part of the train, sir.
No, I don't know. Dislocated means what? I'm not getting it. There is a gap. What gap?
Sir, can I speak in Hindi, sir?
बोलो.
सर जब ट्रेन स्टार्ट होता है सर तो वो एक बार पीछे की तरफ धक्का लगाता है, उसके बाद सर सारा सर जो उसका जो क्लैंप होता है सर थोड़ा थोड़ा गैप में आ जाता है, तो जैसे जैसे ट्रेन बढ़ता है सर एक एक बॉगी ऐड होता जाता है उसमें, और यही कारण है क्या सर उसका?
नहीं, ये कारण नहीं है इसका. There is some mechanical reason for that. ठीक है.
ओके सर.
उसका मैकेनिकल रीजन है कुछ. इससे कोई इसका वो नहीं है, कोई रिलेशन नहीं. ठीक है.
यस सर.
ठीक है. Anyone else?
In yesterday class, you were saying, hello.
Shiva.
Hello?
Shiva, बोलो. Yes, Shiva.
In yesterday class, you were saying in torque equation, torque is dependent on speed.
Yes, that was for load. That was for load. Yesterday's speed torque characteristic was for the load. Today's is for the motor. Okay? They are
Okay,
different.
Okay.
They are different. Yesterday, torque was depending on the speed because we were discussing the loads or mechanisms. Today we are discussing motors. Okay? So, in case of motor, speed will depend on torque. Speed is a function of torque. Okay. Anyone else? ठीक है, तो